Jeff Morrow. What do we mean by unbiasedness?
Yes, unbiased. I'm not sure I would say unbiased, but it's a fair representation of the population.
Repeat and count to 10. Did you hear my conversation with Holmes? So Holmes told me that the sample mean was them going out and randomly choosing some observations, adding up the numerical values for those observations, and then dividing by the number of observations that you got. And that was your sample statistic, which is an example of an estimator. And then I asked him, what do you do with that particular estimator?
Use it to estimate the population. Make a
Estimate population
mean.
Wow.
What did I say?
Estimate the population. And then you start going on about 0 and 1.
What? You led me in that direction.
You didn't finish it.
What am I saying?
So now that we know what we use the sample mean for, Jeff, what do we mean by unbiasedness? Oh, wait a second. I tortured a correct answer out of Jeff. Let me move on to JJ. What do we mean by unbiasedness?
There's minimizing variance. We have minimizing variance in the estimate to bias the increased variance. Uniformly.
Where would you have us believe you bought that t-shirt?
I want 10 points, so...
You're not going to let it slip by that quickly?
Yeah, that's that.
I'm asking you, what's the definition of unbiasedness? We've now established that sample mean, a sample statistic, is an example of an estimator, and we use that estimator to estimate the population mean. So now what do we mean by unbiasedness?
The variance is...
I don't want to hear anything about the variance.
If you do a study and you take a random sample and then you take the sample mean, because of the design of the study, you're not including any bias in that estimate.
JJ, suppose that you do this study and you compute the sample mean and the sample variance, and Holmes replicates your method, and he computes the sample mean and the sample variance, and Green does the same thing. And Yi-Sun does the same thing. Are you all going to get the same sample mean?
No, it depends on the size of the samples.
Wait. He replicated your experiment exactly. Green replicated your experiment exactly. Procedure. Ji-Sun did exactly the same procedure. So you got 1, 2, 3, 4 doing all the same experiment, producing a sample statistic and a sample variance. And my question to you, this is a direct question. Are the 4 sample means going to be equal to one another?
Yeah.
Are the 4 sample variants going to be equal to one another?
Yeah.
So, what do we mean by, well, given that the 4 of you have got different answers, which one do I believe?
Well, the
That's a
sample...
hint when I ask the question, what do we mean by unbiasedness?
It's an estimate that you can have a certain amount of confidence in, based on the size of the sample. The larger the sample gets, the closer it converges to the population mean.
We're going to talk about that particular property in a little while. So where do you want us to believe that you bought that pizza?
I didn't buy these.
Well, the giver wanted you to believe that they got it where?
In Jalisco, Mexico.
Can I get my current point so I can answer the unbiasedness correctly?
Now that you've had a chance to find it there.
Yeah, I understand what you want. Okay.
All I wanted was a definition. I asked you a direct question. What do we mean by unbiasedness? That wasn't a tricky question. But go ahead.
I guess it's in the long run when the values come up with equal the population parameters, like as you.
I think it's better if I move on to Nick.
And what was said.
Nick, what do we mean by unbiasedness?
If you take a number of samples and then average that should approach should equal the population parameter.
In the long run, the sample mean equals the population mean. That means that if we took the average of all the averages that we came up with, the average of all the averages, if we did enough of them, would equal, not converge to, not approach, would equal the population mean.
But that's the central limit there.
No, it's not. No. So, I asked Green what the central limit theorem was a minute ago. So tell him again. Again.
You know the population mean and the population variance when you sample size is large, the sample
As the sample size gets large,
as the sample size gets large, the sample mean has the minus the
get that part. The sample mean has the
normal distribution.
Everybody got it? That's not the same as being unbiased. The central limit theorem tells you something about the distribution of the sample mean. Unbiasedness tells you what the long run average is for the sample mean. So if you could replicate the experiment over and over and over and over and over and over and over again and average across all of the sample means, you would know the truth. So the expected value of X bar is equal to the population mean. That's unbiasedness. Since there's some confusion here, maybe I should do with you guys what I do with my undergraduate students. When we talk about things like consumer surplus, I asked them the other night, what's consumer surplus? Those of you who are economics students, what is consumer surplus? People who are econ students, raise your hands so that I can pummel you. Todd, what's consumer surplus?
I think mathematics is the interval of the Marshallinian demand versus price.
Now we're talking about a group of kids who disavow any knowledge of mathematics at all. So that you're going to have a rough time if you're ever teaching undergraduates, and that's what you told us.
And I qualified the question. Consumer surplus.
Well, so for either one at this point.
Okay, the producer surplus is the additional revenue given to the, not given, earned by producers above and beyond the marginal cost of the unit.
Yeah. A little bit more intuitive than the other one you gave. The definition that I give my undergraduate students is that consumer surplus is the cumulative difference between what consumers are willing to pay and what they have to pay. Very simple. I go through this, I make them repeat after me. Consumer surplus is, producer surplus is the cumulative difference between the price that sellers get and what they're willing to let it go for. What they're willing to let it go for is, of course, their opportunity cost, which is their marginal cost.